This event is brought to you thanks to funding from the CITB Digital Transformation Through Leaders project. For more information, you can visit www.digitalconstructionskills.com or email me, chris@digitalconstructionskills.com.
I've been really excited about this webinar on survey software. So as usual, well, I won't spend too much time talking about it because we've got a range of brilliant guests to hear from. So I'll just get started with the questions and they can tell you all about it. So Gail, you're an experienced engineer. You've you've used a number of different survey software packages from LSS to Enforce, AutoCAD Civil 3D, Trimble Business Centre, TopCon Magnet, etc., etc. So could you explain what survey software is and why we use it on construction sites? And what are the main features within the survey software that you found particularly useful as a site engineer? And perhaps you could explain some of the common, abbreviations and terms we might come across, like CAD or DTM.
Brilliant. Yeah, no, afternoon, everyone. It's really, really good to be here. I would just like to add as well, Saffron, before I answer your questions, it's great to have everyone in the same virtual room. Don't get absolutely everyone, TopCon, Leica, LSS, Enforce. It's Trimble. It's amazing. I'm a bit starstruck at the moment.
I know.
So to answer your question, Saffron, I mean, I think coming from a site engineering background, and as you say, the range of softwares that I've had the experience in using, I think some of the main benefits for me anyway was the ability to, I suppose, more accurately produce measurements on the site. So when I talk about that, I mean things like areas and volumes. Just to give you an example, let's say, we were putting in a 10 by 10 area of concrete with 300 mil deep. You could obviously quite quickly work that out using a calculator. 10 by 10, you would get 100 metre square. Multiply that by 0.3, you would get 30 cubic concrete. But that assumes that the base of where the concrete is going to be sitting on is constant. So where engineering software can come in is that you could go and survey that area, put it onto a form of engineering software so that it'll accurately or more accurately determine the volume of concrete. So it stops you from over or under ordering the concrete. So, and as you know, concrete is quite expensive. So I'll not embarrass myself with stories that I've got from that one, but yeah, it's very expensive stuff. Stockpiles as well, just on the topic of volume. So if you've got a stockpile on site, you've dug out an area that maybe a building's going to be going into, the stockpile's then sitting somewhere on the site, and at come the end of the project, you need to get rid of that stockpile. So in order to be able to find a home for it and a suitable area for it, you need to know how much material's in the stockpile to be able to find a home for it. So whether it means that some of it needs to go off site, some of it stays on site. So again, you could survey that stockpile, plug it into an engineering software, and within a couple of clicks of a button, you can find out an accurate volume. So that has always been a really useful one for me. You can also compare things like two models. So if you've got, let's say, the original ground survey and then the design survey, you can compare the two surveys. Let's say it's an earthworks project, to find out the volume of material that needs to be cut from the site and the amount of material that needs to be filled in the site. So again, you can work out, right, do I need to work out a price for getting rid of some material off site, or can I include it in the overall design? But other things as well, not just volume calculations, but it gives us a good base as site engineers to create setting out models. So of course you get a design from the client or directly from the designer, but to go out and show the people, the workforce that are physically putting in, let's say, curbs or drainage, to let them know where they've to put that, to put those things. So we can use engineering software to create setting out information. So an example of that, drainage. So in engineering software, I can take out all the information that I don't need from the designer and produce just a drainage setting out model, so that then I could go out on site and again, a couple of clicks of a button, and it'll direct me to where I need to go to. It's a bit more complicated than that when it comes to setting out, but when it comes to the software side of it, it really is pretty much that straightforward. Some people might be familiar with the term takeoffs as well. So it's basically a fancy word of saying, how do you calculate the amount of material that you need on site? So again, that's a great one of drainage. So the designer will give you a drainage model, but how do you work out how much pipe do you need? How many manholes do you need? So you could quickly put that into an engineering software. And again, very, very easily, you can create a report in some cases that will tell you how many meters of, 300 mil pipe you need to buy for that entire project. And on the subject of drainage as well, when it comes to water management, and it's completely invaluable, is that especially in Britain, as you all know, we've got the wonders of the British weather to contend with on a construction site. So before you set foot on the site, you've got the best of intentions to manage water runoff on it. But when you're actually on there, you find that there's different areas of the site that will just be flooded that wasn't picked up in the original site walkover or the original site survey. So once you're physically on site, you're able to do a survey of the area, put it into engineering software, and you can physically see it. You don't need to work anything out. You can see it, the way that the water will flow, and where is all that water going to be getting collected. So you're able to do that within the software, quickly analyse so that you can put in mitigation measures such as silt nets or swales, temporary measures that's going to stop you having a problem on the construction phase of your project. But then, of course, you can use it to produce professional looking drawings as well. So you can produce, if you've got the skills, especially for it, you can produce some unbelievable models to your clients. The more professional the drawings that you produce, the better it looks on your company. So when I talk about visual models, you can do things that are colour coded. You can do things that you've got the critical information in tables. The list is endless about what you can do with this software. It looks a lot better than writing something down on a bit of paper and putting that into your health and safety file. So it just allows you to create a more professional set of results, I suppose, at the end of the project. So you mentioned there as well, Saffron, about the difference really between CAD and DTM, and these are terminologies that I've just found over the years it's confusing the industry. When you hear a lot of people saying, oh, I'm using CAD and CAD this and CAD that and CAD this, and a lot of the time people expect that to be AutoCAD when they say the word CAD, but in actual fact it's not. AutoCAD do not own CAD. It's not, CAD isn't a physical thing. CAD is a terminology. It stands for computer-aided design. So it's maybe a bit of good marketing in some senses, but that's what it means. So, like, for example, we've got some survey software providers for us here, and their software encompasses CAD. It's got the CAD capabilities. So you're able to draw different things within the software. Again, and AutoCAD is able to do that as well, again, because it's a CAD software. Where DTM slightly differs from that, so DTM stands for digital terrain modelling. So that is where you can produce this thing called a 3D mesh, a triangulation model, some people will call it, and it's basically a fancy way of saying a 3D surface for the site. So that is the difference between CAD and DTM. So if you had a company that was called, I don't know, something DTM, it doesn't mean that they own DTM. It's just they've incorporated that name into their name, which is similar to what AutoCAD has done. I hope that makes sense. I hope
yes, yeah. So thanks for explaining that, Gail. So what skills do you think site engineers need then to be able to use the survey software effectively? And, you know, how would people get started with survey software if they haven't been using it before now, or if they've been limited to using like the basic AutoCAD, or, you know, for whatever reason, and they want to progress to something which is more suited to setting out and survey related tasks?
Yeah, well, first of all, I think it's very important that site engineers, you there's no getting away from it. You can look at it in different ways of, the digital tools, not just survey software either, that digital in any form, you still need to have the fundamental skills as a site engineer to be able to do your job properly, no matter what digital tool you have available to you. And when it comes to survey software, there's no difference with that. You still need to understand, let's use the volume calculation as an example. If I went out and carried out a survey, put it into engineering software, the number that I should see on the screen coming back to me to tell me the volume of material that I'm looking for, I've already got a ballpark number in my head of what I should be getting. And it could be that I've made a mistake. I've maybe done something completely wrong in my survey. I've maybe not got the software set up properly. Some reasons, the software could identify a mistake in your calculation. So if you don't have the fundamental skills as a site engineer, you're not going to be able to know where mistakes happen. And again, that's everything in digital, not just survey software. But when it comes to the specific skills for survey software, a lot of the softwares now, and we've got everyone on the panel here that have got some amazing softwares. The technology within them is unbelievable. And even though that the technology is so advanced, and the softwares that we've got on the panel today, the usability and the user interface of the software, and this is again coming from personal experience with them, they're so user friendly that people that do generally have experience can quite quickly pick up the basics of how to use engineering software. But for those that have no experience at all, there's a lot to be said for playing about with software. And just getting a feel for it and understanding where different things are. But there's still a need for product specific training. So each of the training providers that again we have on the panel here today, and even some of the smaller outfits that I've had a little bit of experience in, have training modules. Some have formal training that you'll get a certificate at the end of it as well that you can put into your portfolio. But of course, the setting out for construction training that we provide as well, we do product specific training. So you can do that either face to face, you can do it through e-learning, or we can do it through kind of one-to-one virtual training as well. So you can either go to the product themselves for the training, or you can go to external training providers as well for it.
That's brilliant. No, I think that's going to be a really useful resource, that like really clear explanation you've just given us there, Gail. So thanks very much for that. That's brilliant. So Nigel Loriman, the General Manager at McCarthy Taylor, and they provide LSS DTM software. So can you tell us a bit about the benefits to businesses, large and small, about the benefits?
Okay, thanks, Saffron, and thanks, Gail. It was very, very interesting, very clear summary. It helps to pave the way for the rest of us, I guess. Well, when I started selling surveying software back in the 1980s, it was usual to have to explain to people exactly what they could do with instrument data that came out of a survey instrument, and you obviously had to then sell them software. But I think almost 4 decades later, the decision now isn't so much whether they need software, but it's, do they need dedicated survey software rather than a generic CAD package? And I accept, as much as anyone does, that you can get a DXF file off a survey instrument and you can put it straight into AutoCAD. But that, unfortunately, ignores the subject of quality assurance. There'll be very few surveyors out there who could claim to perform a perfect survey that requires no editing. So they would need a program in order to edit that data. And if they're editing it just in a drawing program, that to me is a very high risk for them. Dedicated survey software is your guarantee that your survey satisfies all quality checks, and there'll be no comeback when the results are passed to a third party. And that's the key, I guess. No point in having an instrument that is guaranteed to be accurate, but if you're not checking how you're working, then there's no quality behind any of that. And for instance, if we look at earthworks volumes for a moment, moving on from what Gail said, my personal area of interest, company bosses value every bit of earth moving kit because they know how much it costs and they know how much it's used on site. Plant and machinery can be touched, but software can't. So how does the engineer decide how much muck to move and where he's going to move it and what have you? And the software they use for that is massively underappreciated at the moment. I mean, BIM was supposed to change all of this, and eventually I guess it will. I know Adam's talking about that later. Until then, we'll continue to educate and inform, just as our colleagues on this panel will have to do. So it's a lot of education, I would say.
Brilliant. So what common issues have you found over the years that your customers can resolve by using a software such as LSS?
I think there have always been disputes on site, especially over volumes. And it used to be the practice, I think, that people in dispute used to split the difference. I often heard that for years and years and years. Oh, let's split the difference. And it's always been our contention that our users should never compromise or meet halfway. If they're happy with their data collection, their accuracy, their methodology, then why meet halfway when you can prove what you've done is accurate? More recently, the move towards pegless excavation and machine control, in our view, has been a great thing for engineers. I think many feared that automation would do them out of a job, but peg bashing was never the most glamorous job, as I'm sure you'll testify. Now, armed with the right software, an engineer can import a design, check its integrity, and make any amendments he or she feels are necessary, and then upload it to a cloud server, and then onto the excavator for creation of the site. The engineer then is free to manage a project and quality check a design, which quality checking a design is probably more common now than you could possibly imagine. They can't do this if they're up to their knees in mud on site. So believe it or not, quite a high proportion of our time on support is spent sorting out problems with customers' data or helping them with survey methodology, doing training, etc., when their survey doesn't process. So even once an organization has bought into the concept of digitalization, I think it's the quality and depth of knowledge that customers should be looking for. And that level of support and expertise is only available, in my view, from dedicated companies such as ourselves and applications in CAD.
Yeah, it's very powerful tool, isn't it? So what types of resistance have you encountered then from companies who don't use survey software and you're trying to introduce them to a new way of working?
Well, I think the resistance is never from the person who would end up using it, which is significant. It's usually the ones, they're the ones contacting us in the first place, and they're the ones that are struggling to convince their bosses of the benefits. Thankfully, there are fewer companies out there that refuse to entertain the use of software. What we're fighting against these days is the misconception that CAD software can do everything. It's the universal panacea. Admittedly, you can probably manage to cut I don't know, you're chopping up a plank of wood, you could use a lump hammer for that, but it's never going to give you the right result, is it? But then again, even with the right tool, if you're not trained in its use, you can still create all sorts of havoc. So it's not just, in my mind, the software that counts, it's the whole life support that's lacking from the way too many software vendors out there and is putting off some customers. They get a bad reaction from someone, they buy a generic bit of CAD software, they don't get the level of support they need to sort out problems, and it puts them off. I think the most forward-thinking organisations, I can quote some big names here, like Balfour BT, Jacobs, Royal BAM Group. They involve directors, project managers, engineers, IT, HR, and the decision-making process is done by all of those. More often the spark is the engineer on site, but it spreads throughout the organisation, and then everyone comes on board, and then IT then starts to invest in the solution, and that helps everyone. And of course,
that's what we think about as the kind of digital leadership component in the industry, and we're finding the same with tier ones as well, and also SMEs, that it's about giving the right resources and empowering people, and being open-minded to what all of the different things that need to be in place in order to implement something. So could you explain to us what point clouds are, and explain the differences between them and normal raw survey data from, say, a total station or a GNSS receiver?
Okay, yeah, that's an interesting question, interesting subject. But first we need to decide what the technology, each of these technologies, is used for. So if you're a land surveyor producing a 3D CAD drawing for an architect, you have a choice of both technologies, point clouds or TPS, GNSS, or whatever it might be. But if you're generating a huge terrain model for a large site, then you'll probably lean towards point clouds. Some situations lend themselves to one technique or another, but a hybrid solution is very common, with multiple teams working on the same site with different technologies and bringing all the data together. So a point cloud is created either from a laser scanner or photogrammetry from a drone. And both of these techniques used to be called remote sensing, but people don't seem to use remote sensing anymore. But basically, remote sensing is when you don't actually touch the object you're measuring. Sonar is an example that's been around for decades. So GNSS is Global Navigation Satellite System, and it's actually no different to a total station in that the surveyor walks around with a pole and they decide what points they want to pick up in that survey. So he may be able to collect, surveyor may be able to collect several hundred or maybe low thousands of points in a day using this technology. Or obviously if the pole's mounted on a quad bike, they can pick up many tens of thousands of points in a day. So point clouds are simply a collection of XYZ points, often packed so closely that you can actually see three-dimensional objects. And as artificial intelligence develops, then these objects can be recognized by software, and they can be extracted, and they can be categorized within the data. Coloring the data is also very important, and that's always the case when you do a drone survey, that you'll be using a camera, and therefore everything has a color, and you actually see everything as a 3D picture. The fundamental difference between the two, the GNSS and total station and point clouds, is that point cloud collects huge quantities of data in a very short period of time for analysis later on, whereas GNSS or total station requires a surveyor to decide on site exactly what points he wants to pick up. They normally walk along the strings, and anything they've missed is missed. They've got to go back out on site to pick it up. Point cloud data may only take minutes to collect, but hours or days to convert into a line drawing. Yet GNSS and total station may take minutes to process into a line drawing. But ultimately, a lot of land surveys are still delivered as 3D CAD drawing. So it doesn't really, as far as the customer's concerned, they don't care how the data is collected in some instances. They just want a 3D line drawing. So the surveyors will choose whichever technology is most appropriate for their particular task.
That's really, really good way of explaining it, Nigel. Thanks very much for that. I'm going to borrow that, if you don't mind, in the future. So thanks very much, Nigel. I'll move on to Phil. So Phil Langrish, co-founder of Applications in CAD, who supply Enforce software. So what advice would you give around computer or laptop specification for running a survey software? Enforce is capable of importing and exporting to a wide range of file formats so that files can be altered to suit other people's software platforms. So why did Enforce decide to do this as opposed to only working with Enforce only files?
Thank you very much for the invite. It's a pleasure to be here, this prestigious panel. With regards to specs of PCs, most PCs these days are pretty fast. If we go back, when I first started doing this 20 years ago, the press, the magazines used to have kind of a spreadsheet of all the different packages, and it was how fast you could DTM and how fast you could do this and how fast you could do that. Fundamentally, PCs are fast enough today to do pretty much anything. If I was recommending a spec, I would say probably an i5, minimum 8 gig of RAM, because Windows takes a hell of a lot of memory before you do anything these days. If you're working with decent CAD files, they can be pretty big once you get into them. So memory 16 gig would be great. 8 gig is generally what I find most of the people if they're on site. But if your computer isn't getting the data it needs, then it will be slowed down. And the way to help speed that up dramatically is to use either solid state drives, SSDs, or if you can do M.2 NVMe drives. And if you're looking at point clouds, for instance, a standard hard drive, if you're unfortunate enough to have one, it can move data around roughly 50 megs a second, if you're lucky. An SSD solid state drive will do it at around 400 megs a second. An M.2 NVMe can do it at around 3 gigabytes a second. And there's now a second generation of that, which can do it at 7 gigs a second. So if you're playing with, I say playing wrong word, if you're working with point clouds, and a point cloud, as Nigel said, can be massive. They can range from a few hundred megabytes to many hundreds of gigabytes. So that's probably getting beyond site work. But M.2 NVMEs are pretty common these days. So definitely be thinking about those to move data around quickly. When it comes to file formats, at the end of the day, it's good to talk. Interoperability makes the world go round. All the manufacturers, I'm talking the hardware manufacturers, have their own file formats, obviously, and as a survey software, and I would extend that term survey software to include survey mapping and modeling software, which is probably it's a better description of what our softwares do, especially ourselves and LSS. We're not just bringing raw survey data in and creating a DTM. Think of a Swiss Army knife with 1,000 tools. It's a lot more than that. And that's the benefit of our softwares over generic CAD. But going back to file formats, you have to be able to create XML files. You have to be able to create DWG files or PDFs, because it's going to end up in another package someday. And at the end of the day, not everyone's using our software, unfortunately. Else I'd have a Lamborghini out there, and I don't. So you have to be interoperable, and that's part of the past, the future. If we could all use XML, which was the general idea of XML when it was first formulated, it'd be great. But unfortunately, manufacturers have tweaked that format, and you've got different flavors of XML. So ourselves and LSS have had to adapt our software to read and write different flavors of XML depending on where it's going to go at the end of the day.
Yeah, it does sound like that. The interoperability is coming much more to the forefront now, as an expectation rather than a luxury. So why do you think that site engineers often use AutoCAD as well as other softwares such as Enforce or LSS when they have some or all of the CAD capabilities?
Preconceptions. DWG, DXF originally came from Autodesk. And if you double click a DWG or DXF, it will probably open up in your CAD package. If you double click a PDF, it will open up in Adobe Viewer or whatever you have, to view that in. Our software can import the DWGs and the DXFs and extract the setting out information. It can import the PDFs and reverse engineer that to get the setting out information. Even if there's a coordinate system's being screwed up, we can still work with that. I guess there's just a legacy that CAD has to go into AutoCAD, but our softwares are, as I said before, like a Swiss Army knife with 1,000 tools. We're much better at processing and handling site-specific CAD drawings, layouts, housing estates, earthworks diagrams, drainage, you name it, alignments, road alignments, in our own way, because that's what the software is specifically designed to do. Otherwise, you end up with a CAD package with a plethora of plugins all the way around the outside, and there's no cohesion between those plugins. Our applications are designed to work from the ground up to give a field to finish solution. It's just people have a preconception, and we just have to slowly, chip away at that preconception to try and help show that, you can do some things in CAD, but it's better done in the proper software, which is why we're here.
Brilliant, thanks, Bill. So can you tell us a bit about then how it can be used with underground utilities?
So I'd say that's a synergy with the instrumentation that's been used to pick up the utilities, because obviously you can't see them. They're generally buried underground, so you have to work with GPR. So you're going to have a code list, hopefully, set up in your survey software, and that survey software will upload the code list onto your instrumentation, no matter who the manufacturer is, and it will prompt you for the various attributes. Obviously, one will be depth, and there'll be like signal return quality and all these other kind of parameters that will go in. So your code list will prompt the user as to what they're doing on site, picking up that relevant information. You load it back into the survey software. It will then obviously know what your ground level is, and then take off the depth to give you the proper, 3D level of all these services. We can then obviously attach radiuses and diameters and dimensions to those objects, so that you can then fling it around in 3D and clash detect if you need to, or export into other packages, or import some design information to make sure it doesn't clash and see how it all sits, or load your point cloud in and see what it looks like above ground and below ground at the same time. There's various ways of going about it, but generally it's, especially past 128, you have to do things very specifically. So it's very attribute driven, which is a synergy between attributes and downloading and uploading codes from the instrumentation, from the software to the instrument and then back down again. So there's no loss of intelligence, which I guess is what this is all about, survey intelligence.
So considering the amount of work that goes on underground, this must be music to engineers' ears, and hopefully for people who haven't already explored this type of software, hopefully it's there's a light bulb moment there that is something that is worth exploring. But Gail and I, and Chris, through the work that we're doing with digital construction skills, we hear all the time from engineers that they're desperate to get their hands on this type of software because they know it'll make the job quicker and easier. But their employers just won't let them have it, because they don't understand the value that it can add. But what do you think the message is we need to get to leaders, training managers, decision makers, about the role that survey software or survey mapping and modelling software, which I'm going to call it from now on, the role that plays in improving profitability. How can we help engineers to make that business case?
If I were to name a CAD package, it would probably be AutoCAD or Civil 3D. That's generally where most people perceive, everyone should be working. But for the same reason that you don't play around a golf with a spoon, you shouldn't be using that to do these particular tasks. I've heard so to answer your question, how do you get the point across? If people don't want to change, then they won't. People don't like change. But what generally makes people think twice is when they see something done faster, to a higher standard, and with a lot less effort. And that generally, you have to basically take that horse to the trough and make him drink. And the only way of doing that is to sit on a demo, a bit like we're doing here, but you'd have all the staff, all the members, all the decision makers, the people with the purse strings, show them, like, here's how you're currently doing it, and this is it's taking X long to do it, and then this is how we could do it. And the number of times that I've had people like laughing, joking, swearing, just walking out the room because they've realized they've just spent 2 days doing something we can do in literally 2 seconons. Sometimes it's that dramatic, especially people who draw sections manually. Jesus. So
we need to be getting people, pointing them in the direction of just get a demo, and that will,
Yeah, you haven't lost anything. If someone can demo it for free, which we'll all do, then you can make your own decision. But if we're driving it, then you're going to see the best that software can do. Yeah.
And if you haven't got half an hour or an hour for a demo, then you probably shouldn't be making these decisions about that are going to impact on a company. That's brilliant. Thanks very much for that, Phil. That was just really clear and useful. So thanks, Peter Roberts. So Peter Roberts, you work for Topcon. So survey softwares, like all things digital, are constantly evolving, being updated to include more useful tools for the end user in one package. For example, in last week's webinar or podcast that we did, the panelists discussed machine control, and it was mentioned that machine control and as-built surveys can be sent straight from the cab to the office through the cloud. So can you tell us a bit more about how this works and how survey software connects and talks to the cloud? And in your opinion, why are all businesses not working in this way on the cloud? And what barriers have you encountered from businesses about these digital ways of working?
Thanks for the question, Saffron, and good afternoon, everyone. I'll start by a bit of a definition, actually. The cloud computing is the on-demand availability of computer system resources, especially data storage and computing power, without direct active management by the user. The term is generally used to describe data centers available to many users over the internet. So that sounds, quite involved, but the best analogy I think I can give is your sort of your iCloud, and you've got a device like an iPod or iPhone, and you use your iTunes account. So effectively, they're providing the infrastructure, if you like, in the cloud to provide you with the music, and you're just downloading onto the device what you want at any one time. That's probably the best analogy of cloud computing. So it's scalable. You can upgrade to premium if you want a premium service, or just as a basic user. So what I'd like to do is just sort of explain, we obviously come across cloud sort of solutions in both the geomatic side, the land survey side, and the sort of the machine control. So I just want to just show that comparison, or just talk about that comparison. So on the geo side, you can have a project that sits in the cloud. You can allow your field crews access. So it's a management tool. You can allow your field crews to access that data. You can send designs to the field, and they can send as-built data back to the office. So you've got that two-way communication. It means you can keep all your project data in one place. It means you can provide roles or give access to different types of people. So you could have a client that could jump in as well. You could have he could place revisions on. The whole idea is that we could get that quickly out to the field for setting out. The surveyors, they can do their topographic surveys, and they can very quickly upload it at the job site. No need to go to an office. Upload the job site, and it can be worked upon by the office team, if you like, while the survey is still ongoing. So it gives progress. And then if you want to take it to a different level, we can do cloud surfing, as it's called, which is basically integrate with other manufacturers' clouds. So, for example, I'm thinking of, and it's been mentioned probably ad nauseum this afternoon, AutoCAD, but AutoCAD have got 360 cloud, and Bentley have got ProjectWise. So you can sort of hop between the clouds. So it's about sharing the data. Now, from the geomatic side, from the topo side, Wise, we don't think the uptake has been that great, and there's a couple of reasons for that. It's basically that it trying to actually demarcate what the savings are. I mean, the fact is that on most construction sites, for example, they'll be able to jump into their office environment, access the drawings, or the access to the internet. So it's sort of having access to be able to immediately send the survey back to the office is not a primary concern for them. You've also got sort of competitive services like Dropbox and OneDrive. And for some of the big tier one contractors, things like where the server is located is a bit of a security issue. So there has been that kind of reluctance, I think, from the survey side anyway, to adopt these cloud services. But when we come to machine control, or rather, before I go into machine control, I'll give you a couple of examples of those who have successfully used cloud solutions. And that would be maybe the company only wants his field crews to send in their data every night, so it's secure rather than at the weekend and risk losing some data possibly during the week. And these things happen. We had a customer who was working on a night shift on a lane closure project. He'd finished the shift at 6 in the morning, didn't want to drive back to the office. He could upload his, from the field, he could upload his survey to the cloud, and the office could process it while he's away in bed. And then he comes back on his next night shift, and they've sent him drawings for the next day, for the next shift. So it has worked in a couple of circumstances like that. So that's on the geo side. On the machine control side, I think it's a lot more clear cut, and it's basically because time is money for machines. So what you can do, the most obvious feature of machine control is that you can communicate between the office or the surveyor or the engineer can communicate directly with the machine. So the advantage therefore you've got is the fact that you can, if the design changes, you can squirt out the new design, and it can be uploaded not only to that machine, but also to all the machines in the fleet, so everyone's working on the same design. And that the traditional method was go out there in the truck, with a USB or thumb drive, plug that into the machine and update the design. So by which time you've done that, there's time has elapsed, and you've got expensive rework to cope with the sort of the issues that you've got there with the delay. You've then got sort of remote viewing and remote control. So that's a fantastic support tool, because it means that your engineer can jump in and have a look at what how the model looks on the machine. Ideally, he's sort of sanity checked it before in a program, one of Nigel or Phil's programs, before it's gone out to the machine. But he can actually see what the driver's looking at. He can also do training, which is a massive thing, especially with COVID at the minute. He can actually do one-to-one with the driver and training. So you've got that sort of communication option as well, or advantage. Moving on from that, we can actually then treat the machine bucket as a pogo pole, as a detail pole. So we can actually ask the bucket to record the lowest point it goes on an excavation. That will then create a DTM, which can then be sent back to the office. So you're actually getting an as-built survey from the machine, okay, which is, again, is massive. So how many times have we had to send someone out to do a weekly measure, and it's all day on a Friday for a big project? So this means that the DTMs can be sent back to the office. It can be, that's all the machines, if they're all hooked up, they can be scheduled so that they email that report to a wide distribution list. So that can be then updated. Then move it on a step further, we're starting to talk about connections, cloud connections, to not only excavators and dozers, but also haul trucks. So you're starting to bring in a whole sort of project management, all being controlled by the cloud. And that then turns, basically, you're into a sort of an office, being able to, in near real time, be able to manage that project, giving all your sort of the key sort of elements of the excavation. So that's way we can sort of use cloud solutions sort of to the max, really. What advantages are there? There's the obvious health and safety man-machine interface, so you're not having a surveyor working around the machine doing the as-built survey of the excavation. The engineers can sort of stay in one place and actually get all this information, collate it, merge DTMs together, and come up with measures and things like that. And then we've also got event logging, so you can actually have a record, a QA record of what the machine has done. You know, what depth of offsets has he put into his 3D machine model. So again, we can. It's tempting to think of it as Big Brother, and it is, but it's in a positive way. Hopefully, it's been viewed as a positive way. Then, as some manufacturers are getting more on board with the machine manufacturers, we're starting getting API data from the machine. So idling time, running time, you know, in this time when we're looking at having sustainable construction industry, you know, trying to save fuel costs, emission costs, trying to have leaner construction. So all these things can be monitored and made more efficient using the cloud solutions. So have we got a take-up of this? What are the barriers? You know, how can we actually, what are we seeing in industry? Well, we're finding out that a lot of people don't know we can do this. That's it. Ignorance is a big thing, and that's where DCS comes in, you know, education of clients, etc. Also, under the sort of the idea of change, you know, nobody likes change. We all know that, as seen by the contributors today. Traditional working practice and site engineers who are fearful of that sort of change because they think it's taking their occupations away. But the way to combat that is to say, well, look, guys, we want you to be more data managers. We want you to be able to handle data. You know exactly what that machine driver wants to see. He doesn't want a lot of the superfluous information that's provided on CAD models. He just probably wants a left-hand channel, right-hand channel, and a surface to dig to. And so that they can dilute that information to exactly what the driver wants. Then they can actually also reinterpret the data that's coming back from the machine as a 3D model and a weekly measure and a progress, etc. There's a bit of a myth that machine control and cloud solutions are just for big jobs. And that's a fallacy. You know, they see these big motorway jobs, etc., big projects. But even this, if you can imagine a site engineer having several sites to work on, running around like a bit of a headless chicken, bit of setting out here, bit of setting out there, he effectively could manage all those sites from his desk pretty much by sending out the right models, sanity checking the models, sending them out to the machines. And it's education of the drivers as well, of course, so that they understand what they're receiving. So really, one of the questions is, why should I invest in machine control? And it's because as sort of plant operators become more automated, it's the decisions that we make on sites are highly influenced by this data that's coming in. And I think, you know, we just need to, I suppose, engage industry in the fact that all these, the benefits of sustainability, environmentally friendly, and leaner working, more productive working can be sort of gained through these cloud solutions.
It's phenomenal, really, and I love the point you made about it's not just about getting out there, getting the job done as quickly as possible, but all of the data that can be collected saves somebody else measuring that data separately. But it's just a much higher quality and, you know, a much richer set of data that can help decisions and you know, record keeping and payments to flow more smoothly. So, I mean, it just, everything you've just explained there just seems like a no-brainer, Peter. So we need to get on with that, all our collective jobs, don't we, of raising awareness and helping people see, how, you know, the benefits that this can bring. So thanks very much, Peter. That was great.
Okay.
So we'll move on to Adam Ball now. So Adam Ball, you work for Leica. Would you give us an overview of BIM and explain, you know, where the currently available softwares will fit into BIM?
Yeah, sure. Firstly, thanks very much for the invitation. It's an honour to be on the panel. It's the first time I've done one of these things. But yeah, so an overview of BIM. Well, BIM, of course, stands for Building Information Modelling. And fundamentally, it's a process rather than just a 3D building model. The purpose of the BIM process is to ensure that appropriate information is created and made accessible in a suitable format at the right time, so that better decisions can be made throughout the design, construction, and operation phases of a building. It's not just about creating a 3D model. As I say, the information part really is as important, if not more important, than the modeling element of BIM. And it's not, should never be treated just as an add-on process to the building construction cycle. So it's fundamental to the way that a project is set up and run. It's not something you can just suddenly introduce partway through a building project. And the whole process is designed to ensure minimal wastage during that life cycle. It's been proven that if you can introduce BIM processes in a correct way, then you can actually save between 20 to 30% in project costs just in saving wastage alone. So that's how I see BIM as a process and how I generally kind of describe it. So,
sorry, go on.
Yeah, sorry, yeah. So data from survey softwares, it's more about where it fits into the BIM process, I think. Initially, survey data, of course, provides initial spatial information. So, for example, a survey, whether it's a topographic survey, measured building survey, utility survey, the survey information drops in there. So that initial data is what the designer would be able to then use to make sure his design actually fits into the space and the environment that's actually there in the real world. So he can't design without that real world information to make sure that his design works within there. So that's the first place really that we see survey information being used in the BIM process. Secondly, it gets used within the construction of the building. So this is the setting out phase. So essentially the survey information can be passed back through the survey software, for example, to be able to provide information for the site engineer to be able to then lay out accurately and position that design on the ground, so it sits in the correct place within specification. So there's two places for survey information. And the third place, and generally viewed as the final place, is actually recording the constructed position of the building and the elements within the building. So this is generally referred to as the as-built phase, or could just be the verification phase, or verifying that the actual physical construction has been constructed as per the design to within the specified tolerances. So that is where I would say building software and survey software and survey information fits within the BIM process.
Very interesting. So can the data from the survey softwares be used in a common data environment, even if the softwares aren't fully BIM compliant? You know, the software packages currently that currently available, are they going to need to change to keep up with the different levels of BIM?
For example, we're not at Leica, we're not aware of any particular limitations to data types that are able to be used in the common data environment, because BIM is essentially a collaborative process. As Phil pointed out earlier, essentially you need to be able to deal with any data types really that are available, as much as anything. So there shouldn't technically be any limitations as to what information can be provided in that respect. Compliance, of course, relates to the ability to track and demonstrate the suitability of survey data, as well as record the construction process. So it's important, not necessarily within the survey particular survey software, but that survey software can provide reporting and analysis tools in order to be able to document the processes that have been followed, to prove that the work that's been done has been done to the required standard. It's also quite important that the software can access the common data environment, as Peter pointed out, with the cloud connectivity. It really can save an awful lot of time and effort if the designer can get the information to the guy on site in good time, and the information can get back to the designer. So any problems found can be dealt with in a timely fashion, which is where typically an awful lot of time is saved and problems are solved. If they can be solved early, typically they are fundamentally cheaper to solve than if they're discovered later on, and far more rework has to take place.
Yeah, so if companies, if they give themselves the capability of, even if they're not looking at BIM right now, but if they can bring on that capability of the survey mapping and modelling software, then they are making themselves more able to work with BIM and feed into that process. And, we often hear from engineers that, again, we work with engineers, and that you just hear this conversation all the time that they're issued with only, 2D flat PDFs, and, they're really struggling to get that 3D digital data from designers. So how do you think as an industry we can overcome this blockage, which I think is really hampering progress and costing the industry a lot of money? Yeah,
I agree. We had the query from a chap on the chat earlier, and it's the first query that pops through is about PDFs, and it's incredibly difficult because the site engineer these days is perfectly, with most of the site software, the field software that he's got available to him, is more than able to work with 3D data. And of course, it makes it so much easier if you can visualize the world in 3D rather than just trying to interpret a flat 2D drawing, which is very often very complicated with dimensions and pop-outs and revision clouds and all sorts of things, and of course tends to be out of date from one instance to the next as revisions are made and a revised drawing is put out there. So what we're seeing at Leica is an awful lot of tier one contractors, for example, creating roles that they refer to as something along the lines of a digital engineer. So this is a guy who might receive the information from the client or the designer in the 2D PDF, and what they're having to do is actually take that 2D information and reconstruct a 3D model to make it more suitable for site setting out. So at the moment there is no clear-cut answer to this question. So what's happening is that they're being creating this 3D model because they know, the digital engineers know, that the field software is capable and is much better able to work with 3D information than the PDF. You take a PDF, it always has to be converted into useful information, basically, rather than, I would just view a PDF as being a picture, really, of the site, rather than useful dimensioned information. But yeah, so what this tends to mean is that these digital engineers are able to take the model objects and actually turn them into more useful, better represent what actually happens in the real world setting out. So, for example, in a building, a designer may model a column that runs all the way from the ground floor all the way up through to the upper story, because it's easier for him to model that way. But of course, that's not how it's built. It is built level by level by level. So the digital engineer, for example, might take that single column and create in his setting out model the column level by level, and he might also add more useful attribute information. For example, the amount of rebar that needs to go in it. This might be as part of the attribute information held within the object, within the model information. And the form, what I would refer to as the DXF of the BIM world, is a file format called the IFC, which essentially is designed to be translated across and read by pretty much any software that's able to read BIM models. But that can hold attribute information, and of course, it makes it much easier if you can just tap on an object to read the attribute information, rather than having, a whole load of pop-outs and writing cluttering up the drawing. So it really is just a case of trying, as the other panelists have said, very much trying to educate people and trying to get the this collaboration, which is essentially what BIM is all about. It's all about collaboration in order to be able to get an overview and a fundamental understanding of the project. And essentially, that collaboration at the moment typically only extends to, if you like, the drawing office. It's it's the architects, it's the structural engineers, it's the MEP designers. They are collaborating. They're the ones creating their models, putting it into the common data environment, that space. But it appears to me that the bit that needs improving is the collaboration between those guys and the guys actually building the building at the end. What do they want is where at the moment the sticking point appears to be. So very much as the other guys are saying, it's this education of everyone and trying to make the designers understand as much as the site engineers what the site engineers' pain points are, and vice versa. The site engineers letting the designers know where their pain points are.
It's mind-boggling, really. That I know that some of the service softwares have the capability to read PDFs and recreate them back into 3D models, but really, we shouldn't be having to work like that if there was, some proper joined up thinking, at the top. Then a lot of time and money could be saved in this industry. But thanks, Adam. That was absolutely brilliant. Thanks for clearing up, demystifying some of the BIM elements of the, how they interact and what the benefits can be. Thanks. So, finally, we'll move on to Ted from Trimble. So, Ted, thanks for joining us. So, Trimble have got a massive range of digital technologies, going from machine control, right through to augmented reality. So, when it comes to engineering software, you've got Trimble Business Centre, which has been extremely successful in the industry. But we are hearing more and more how Tekla is being used as an alternative to Revit. So could you give us a brief explanation of the difference between Trimble Business Centre and Tekla, and who might use these?
Yeah, sure. First of all, just want to say, as everybody have said it, thank you very much for the invite. the very short kind of explanation of what's the difference between these two software packages is that the Tekla side of life is really focused on the kind of building side, the building construction element, and these type of thing. And Trimble Business Center, it's a more focused maybe on the hardware integration and probably more towards the civil side. Now, Trimble, we make a lot of hardware for various types of things. So total station, GNSS receivers, GIS equipment. We also make mobile mapping data that contains, again, an awful lot of different hardware components, such as IMU systems, post-processing GNSS, and all this type of things. So, as you know, one of the manufacturers who do these type of things, we need a platform that can kind of interface and process a lot of the kind of machine code type data that some of these systems produce. And TBC is really for us our kind of central hub for having the capability to read in all these type of data. Some of the instruments are easier than others to just kind of get the raw data out, so the total station and GNSS receiver. If it's just kind of coordinates you get out, others requires more specialized side of it. So, for example, people doing post-processing, GNSS type of things, we really need to have the capability to read data more at the raw side of things, or we're processing mobile mapping data, which contains GNSS data, the whole IMU side of it, the trajectory, and these type of things. So it's not as easy as just to kind of export something out of it, and we need to get that in. And TBC for us is kind of the package that does all that. So all the type of sensor data that we make, but not only our own data. Contrary to a lot of what people think, we actually are promoting kind of the open standard side of things as much as we can, and would love to integrate more of sensor type into that type of software. And then TBC also has a number of kind of what I would kind of call the core survey and the civil engineering type interface. We're probably competing a little bit with Phil and Nigel's software on some places. But it's that type of things that we operate with the TBC side of things. But as I say, also mobile mapping becoming a very important part of it, but also the GIS element of what we're doing is also interfaced into this. If you start looking at the Tekla software, now you're kind of more over to the building side of things, the building construction, but not only the kind of the contractual side of it. Tekla is a 3D modeling software, so we can really model advanced construction elements for not only for the build, but also for the manufacturing side of things. So the Tekla software is used in kind of pure manufacturing. So where you have steel, it is really manufacturing down to the millimeter side of it, based on the drawing that comes out of the Tekla software. This is a really rich 3D modeling software for the kind of the high detail side of things for what it's doing. Also for the kind of precast side of things and concrete. So much more into these type of things where you can do very advanced on rebar side, modeling rebar side of things, and then, of course, you also have the whole kind of business element of the building side of using the Tekla software. So that's kind of the rough difference between these two packages. But important for us in many ways that there are common elements in these two software packages that also can, cross. So it is important to have, data compatibility between them, and it kind of falls into what some of the other panels have been speaking about, the whole model side of things, the 3D element, the BIM element, the capability, for example, in the Tekla side to export a BIM file, an IFC file, or something like that, which which is then kind of going out to site and take this on, setting this out to the field element of it, whatever manufacturer that is to use that. So this can be extracted and this can be sent for doing then more traditional set out work, and also then the other way, coming back in again for various type of checks.
Brilliant. So what is the range of skills then that you need to be able to like get the best out of this kind of engineering software, and who is best placed to use those skills? And just finally, Ted, is there any other points you want to pick up from, and anything else that we've talked about today?
So I think I want to just start with the last one, which Adam mentioned a little bit, operating in the UK, and we can very clearly see kind of on a kind of bigger worldwide scale that the whole BIM element is something that is growing. It is coming in, and as Phil has said many times, that there's a lot of people who kind of don't like the change. This is how I always done it, and these type of things. But I know that these things are slowly changing, and sometimes it's changed with a bit of, you're putting your foot wrong a little bit here and there and stuff like that. But the industry in general is kind of pushing and pulling the same way. We're seeing a lot of governmental type organization who is actually pushing the BIM side of things a lot harder in various countries in terms of where it is and stuff like that. So, and with that, we as a manufacturer, or any of us as manufacturer, also has to be better at creating the type of software so people can use. And one of the thing here was, how easy are these things to use in the field, for example. And we probably have a job to do there in order to kind of take the traditional 2D drawing working and make it better, so it's easier for a user in the field to do that. And that is a challenge. But we are seeing that these changes are happening and they are coming. But they do happen at different speeds in different places in the world. In terms of skill sets, there is no software that's kind of optimized for doing everything. And depending on what industry you're in, I think you need a particular kind of skill set for doing that. The pure surveying side of things is one skill set in terms of what you're doing, and I meet people who's good at that, and I also meet people in the kind of building construction side who doesn't know too much about these type of things, and the coordinate system side and that type of stuff. But of course, you go into the precast and the manufacturing of that be steel or rebar and other things, then you'll probably be more specific skill sets for that. And I also know that there are a number of educational systems out there that kind of cater for these specific elements of what it is.
Brilliant. Thanks, Ted. I mean, that's just been absolutely brilliant. This whole hour, every minute of it has just been like gold dust. In terms of the education material that we can create from this, and how we can repurpose it to help get this message out here. Chris, I don't know if there's any questions, just quick questions that you want to pick up from the chat to ask to the panel.
Oh, I think we've probably maybe dealt with most of them. I think the problem with the PDFs and clients, and I think as well that is educating clients is maybe a thing that maybe we need to be looking at as well, Saffron, because maybe they don't see the value in a lot of this stuff as well. And the information format they're producing some of this stuff. So, but no, that's been fantastic. Again, I don't make any apologies for overrunning, because it was all valuable material. And I'm really grateful to everyone for agreeing to come on today. So thanks very much, everyone.
Yeah, it's been absolutely brilliant. So can't wait to get that made into a podcast, and maybe break it down into some shorter videos so we can help to get you know, the right bits to the right people at the right time. So
but I think the golf course, the spoon in the golf course is probably the one that's going to stick out. I think that's the headline one there. You know, so thanks for that, Phil.
you can take that and do what you like with it.
Great stuff, guys.
Phil.
Sorry?
Is that based on personal experience?
Yeah, I'm shit at golf. I might as well use a spoon.
Right, folks.
Yeah, with you.
Thanks a million.
All right.
All right.
Pleasure.
Off you go and get your tea now. All right.
Thank you very much. Cheers.
Bye.
Bye.